These are the 4.6 notes for pre-calc. Our essential question, how do I find the zeros if I am not given any to start with? So we learned this back in Algebra 2, so this should be a little bit of a refresher. We are going to start by making a list of possible zeros. Possible zeros means they might be answers, but they might not. So you've got p's, which is the last term, and q's, which is the first term. And then we're going to write them as fractions, p's over q's. So the first thing we're going to do is just practice writing out the list of p's and q's. You're going to start by making the list of p's, all the numbers that multiply to make 5. That would be 1 times 5, as well as -1 times -5. So we'll just write them as plus and minus. Plus and minus 1, plus and minus 5. You do the same thing with q, any numbers that multiply to make 3. That would be 1 times 3. So I'll write that as plus and minus 1 and plus and minus 3. Then you write out the p's over the q's. So you're pretty much writing 1 and 5, dividing it by 1, and then 1 and 5 and dividing it by 3. Now at this point I get a little lazy. I don't like to write the plus or minus sign because I don't like to write it so many times. I'll just go ahead and add it back on at the end. Any numbers that divide out, go ahead and divide. So 1 divided by 1 is 1. So I'll just write plus and minus 1. 5 divided by 1, 5. 1 divided by 3, just leave it as a fraction 1/3. Same with 5 divided by 3, leave it as 5/3. That is our list of potential answers. Notice there are 8 numbers on that list, 4 numbers with a plus and a minus sign, giving you a total of 8 possible answers. Example number 2. We'll start by doing the p's, which is the 6, and the q's, which is the 2. Now, even though that 6 is negative, because we write a plus or minus sign on everything, it's not going to matter whether that 6 is a positive 6 or a negative 6. Numbers that multiply to 6 would be 1, 2, 3, and 6. The numbers that multiply to 2, just 1 and 2. We write our possible list of p's over q's, all of the list of p divided by the first q, and then all the list of p divided by your second q. So it's going to look like this: 1 over 1, 2 over 1, 3 over 1, and 6 over 1. Then I do that same thing, but with the second q, the 2. 1 over 2, 2 over 2, 3 over 2, and 6 over 2. Then divide out all the whole numbers. So my final answer would be plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 6. 1 over 2, I would just leave as 1/2. Now this 2 over 2 right here, 2 divided by 2 is 1, but I already have 1 on the list right here, so I don't need to write it again on my list. Then I move over to 3 over 2, and then 6 over 2 becomes 3, which I, again, already have on my list. So no need to write your answers again. So just put a box around this final list of numbers. These are my maybe answers. They're not definitely answers. We would have to check them to see which ones work. Problem number 3, a little bit longer, but we're still only focused on the p's and the q's. Here your p is 18. Your q for this one is an invisible 1. All the numbers that multiply to 18 would be 1 times 18. And sometimes if I know there's going to be a lot of numbers, I just kind of work it like this, the 1 times 18, and put the 18 at the end of the list. And then I know 2 times 9, and then 3 times 6. My q is just 1. Anytime that happens, you're just going to divide all the p's by q. But instead of writing that out, I know that when I divide all those numbers by 1, I'm going to get the same exact list. So instead of doing all that extra work, I'm just going to say, you know what? This is my final list of answers. If q is 1, P is the final list. Because you're dividing by 1, which means it wouldn't change anything. On the back side, we're going to find all the zeros. So we did the finding the potential zeros, the possible zeros, and now we're going to actually check to see which ones work. So the first thing you're going to do is start by listing your P's and your Q's. So P's, Q's, P, 1 is your Q. That's always a good thing. It means your list is going to be a little bit shorter because you won't have to divide out those numbers. Numbers that multiply to 15, 1 times 15, 3 times 5, and I like to put them in order. Q is just 1, which means my list is going to be right here. I don't have to divide those by 1 because I'll get the same thing. So first step, list the P's over Q's, right? Make your possible list. The second step that we're going to do is we're going to actually have to start checking these. And the way I would like you to check them, I would like you to check the positive number first, then the same number but with a negative. Then move on to the next one, positive, then negative. So for this problem, we'll start by checking positive 1, and then negative 1, then positive 3, then negative 3, then positive 5, then negative 5, etc. As soon as we find one that works, we'll try to write our new polynomial. So I'll start with positive 1. 1, 7, 7, and negative 15. Those are my coefficients. 1, 7, 7, and negative 15. And we'll do synthetic division again. This one doesn't have any imaginary numbers, so it should go a lot quicker. Drop down the first 1. 1 times 1 gets me 1. Then I add the numbers on the inside, 7 plus 1 to get 8. Multiply 1 times 8 to get 8. Add 7 plus 8 to get 15. Multiply 1 times 15 to get 15. Add those to get 0. That means that positive 1 is one of my answers. So if you want to, off to the side, you can write a list of all your zeros. Because of this 3 right here, we know that there are going to be 3 answers. And I've already found one of them to be 1. Now, the 1 does not come as a pair. It's not like 1 and negative 1 always travel together. That's only if you have imaginaries. So what I'll do now is I'll take my 1, 8, and 15, and I'll write that as a depressed equation. So this 1 represents the number in front of the x squared. The 8 represents the number in front of the x. And this 15 represents the constant number. And we can set that equal to 0. And then we'd have to factor. So this third step, write the depressed equation. And then try to solve. My numbers that multiply to make 15 and add to 8 would be 5 and 3. So this is what we call factoring. I know both of my numbers have to be positive in order for them to add to 8 and multiply to 15. Then once you have the factors, remember all you'll have to do is switch the signs. So x plus 5 would give me an answer of negative 5. And x plus 3 would get me an answer of negative 3. And there's my final answer of zeros. Those are the ones that actually work, as opposed to in this blue box here, those are the ones that might have worked. All right, let's try example number 4. We'll do that same process here. We'll start by listing the P's and the Q's. Remember, P is always the last one, Q is always the first one. Another one where Q is 1. That's going to be helpful. Just know that's plus or minus 1. All the numbers that multiply to 75. Let's see. We've got 1 times 75. 2 does not go into it. I've got 3 and 25. 4, nope. 5 goes into it. 5 and 15. And because Q is 1, this is my list of potential or possible zeros. My next step, I just start down the list checking one at a time. So I'm going to start by checking positive 1. List your coefficients, the numbers in front of the x's. 1x to the third, negative 3x squared, 25x minus 75. So you're going back to these numbers right here. Drop down the 1. Then you multiply 1 times 1 to make 1. Take a second and see if you can finish that synthetic division. All right, you should have gotten negative 2, then negative 2, 23, 23. And that answer I know is not 0, so I don't even want to mess with typing into my calculator. If it doesn't get me 0, I'm not interested in it. So 1 didn't work. All right, now I have to try negative 1. Actually, that's not going to be enough space. Let's try it over here, negative 1. All right, we line up our coefficients again. 1, negative 3, 25, and negative 75. Take a second and see if you could do that synthetic division. Again, that does not give me 0. It's going to get me a very large negative number, but I know it's not 0, so I'll cross that out. The next number you want to try is going to be the positive 3. All right, let's see what happens here. 1, negative 3, 25, and negative 75. Take a second, try that synthetic division. And finally, we get an answer of 0. So that means that 3 is one of our zeros, one of our answers. To finish the problem, we move on to step number 3, write the depressed equation. So we'll take the equation. My polynomial started off with x to the third. So my new equation is going to represent x squared. So this 1 represents 1x squared. This 0 is 0x. And that 25 would be plus 25 equals 0. Now, most of the time, if you have a 0x, we don't need to write it. So this, we can probably just write as x squared plus 25 equals 0. No need to put that extra 0x in there. We will solve this not by factoring this time, so you don't need 2 sets of parentheses. What we'll do instead is we'll move the 25 to the other side and make it a negative 25. To get rid of the square, we will square root both sides. Now, when we take the square root of a negative 25, we have to put a plus or minus sign. Square root of 25 is 5. And then because you have this negative number in there, you have to put an I to show that it's imaginary. Remember, you would not normally be able to take the square root of a negative. You can only do it if you put the imaginary number I next to it. And that's actually 2 answers. You have the positive version and the negative version. So if you wanted to make a final list of zeros, you would have 3, 5i, and negative 5i. All right, for our last problem, example number 5, notice this one starts off as x to the 4th, which means we're going to be eventually looking for 4 answers. Let's start with our p's and q's. Numbers that multiply to 18. Take a second and see if you can find all the factors, all the things that multiply to 18. All right, my Q is again 1, which means that this is my list I'm going to be working with. Now it's time to start checking. I'll put a 1 there, and we list all the coefficients. 1, -3, -7, 27, and -18. Multiply the outside 1 times the bottom 1 to get 1. Add -3 plus 1, -2. Multiply 1 times -2. Add. Multiply. Add. Multiply. And add to make 0. That means that positive 1 is one of our answers. That's great. So what we'll do now is we'll write our depressed equation. This started off as x to the 4th, so this is going to represent 1x to the 3rd minus 2x squared. Bring down the -9, put the x there, plus 18 equals 0. So now we have a new equation. The problem with this equation is we can't just factor this, and we can't solve it the same way we did on the last one where you subtracted the number and square rooted. So it's almost like this now is your new equation, and we're going to have to keep working our way down the list. So we're going to have to keep checking. So the next one I'm going to check is -1. But when we do this, make sure you check based off of these new purple numbers. 1, -2, -9, and 18. Bring this down. Multiply. Add. Multiply. Add, multiply, and add to get 24. That does not work. That means -1 is not one of our answers. The next number in our blue list up here is +2. We still want to use our purple equation, so we're going to use +2, but with the purple numbers, 1, -2, -9, and 18. Take a second to try that one. All right, we got an answer of 0. That means that 2 is also one of our answers. So now that I've gotten another 0 here, I can write a new depressed equation. The purple was x to the 3rd, so I'm going to write one more, one exponent lower. So I'm going to write this as x squared. I don't need that 0x. I'm just going to ignore that. -9 equals 0. Then you can add 9 to both sides and square root it. This time I don't need a I because I'm square rooting a positive number. So that gets me x equals plus and minus 3. So my final list of answers for this problem, I've got this 1 right here, the 2 right there, +3, and -3.